Friends, welcome to all of you in module 6 of the course Langchain Mastery. In today's module, we will see how to work with vector databases. In this module, we will learn how to integrate vector databases with Langchain. These databases allow us to store and retrieve document embeddings efficiently for context-aware application like RAG. And RAG is known as Retrieval Augmented Generation. Our objective of this module is to understand what vector store are, how to generate the embeddings, how to use FAISS with LangChain, and how to build a document question and answer bot. Okay, so let's move forward with step number one. So, step number one, first of all, we have to install the required packages. Okay, so the first line of code I have written to install the required packages, that is pip. Pip is nothing but Python install package. Install minus q langchain. After that langchain Google Gen AI. After that FAI is a CPU. After that langchain community. So pip install minus q. This is a collab magic command that runs the pip install command in background. And why minus q is used? Minus q stand for quiet, meaning it would not show installation progress. And LangChain, as you already aware, the core LangChain library. And LangChain Google Gen AI, it provides integration with Google Generative AI model like Gemini. Whenever we have to create an integration with our Gemini model, uh, for that purpose, we have imported LangChain Google Gen AI and FAISS underscore CPU to install FAISS, that is Facebook AI Similarity Search, a library for efficient similarity search. It is developed by Facebook and clustering of dense vector. So this library is used for similarity search and clustering of dense vector, which is compiled for CPU usage. And LangChain community contains various community contributed integration and component for LangChain. Okay, first of all, let's run this code. While this code is running, let's move towards step number two. So our step number two is to set up Google Gemini API. So first of all, I have imported OS. After that, import environ Google API key, and after that, I have given my API key. You can use your own API key. You can create your own API key by visiting the Google Market Suite website. Okay. So our first step has been completed. Okay. So our all packages has been installed. Okay. And our second step is to set the Google Gemini API, which is also completed. Now, our third step is to load Gemini LLM. Okay. For that purpose, our code is from LangChain Google Gen AI, which I have already imported here. You can see LangChain Google Gen AI. Here I have imported. Now, its utilization of that package come in step number 3. So from LangChain Google Gen AI, import chat Google Generative AI, and we have created a LLM object and given Google Generative AI, and we have given our model and temperature. Temperatures often we have to put between 0 and 1. More temperature means more creativity. The temperature tending to 1 means our model will be more creative. Okay, what is a vector store? So, a vector store is a specialized database that stores high dimensional vectors, that is known as embeddings. It allows fast similarity searches, which is essential for retrieving relevant documents. And LangChain supports several vector stores like FAISS. It is used for local, fast, and it's also open source. The second vector store is ChromaDB, and third one is Pinecode. And there are also several multiple vector stores. We will see how to load and split the documents. So this code loads a sample documents, splits it into smaller chunks, and prepares it for use with a vector store. So before creating the document and loading the document, I want to show you the status of my file. Okay, our document name is Agentic AI Python notebook.txt. Okay, so first of all, let us check is there any document with the same name in our file. And you can see there is no document with the name Agentic AI Python notebook.txt. Okay. Now, what I will do, I will run this code, and after that, we will see the status of our file. Okay, is our document Agentic AI Python notebook test is loaded or not? Okay, so here I am closing the file explorer. Now, I will explain the code. After that, I will run the code, and after that, we will see the status of our file. Okay, so first line of code you can see from langchain.txt splitter import character text splitter. It import the character text splitter class. And why what is used of this class? This class is used to divide text into smaller pieces based on character count. Okay. Now the second line of code is from langchain.documents loader import text loader. So the purpose of this text loader class is to load text content from file. Okay. Now I am going towards the next step, and in this step we will create a load a sample document. So with open and our document name, agentic AI Python notebook.txt, w as f and f dot write and our content of our document. Okay. So I will explain this code. So you can see with open and f dot write. What is meaning of this? So this block create a new text file with the name agentic AI Python notebook.txt and write the provided sample text into it. Okay, and loader equal to text loader, and we have given our file name. It create an instance of text loader to read the content of our newly created file. Now our the code document is equal to loader.load. It's load the content from the file into a list of document objects. And text splitter, it is used to create a character text splitter instance. Okay. And uh, you can see some parameter over there. Chunk size equal to 100 and chunk overlap is equal to 10. So chunk size equal to 100 specifies that each chunk should aim for a maximum 100 character, and chunk overlap equal to 10, it specifies that there should be an overlap of 10 characters between consecutive chunks. This helped in maintaining context with splitting. And docs is equal to text splitter dot split documents. The last line of code, you can see here last line of code, it splits the loaded document into smaller chunks using the configured text splitter. The result is stored in the docs variable. Okay, so I have already shown you the status of my file. Okay, now I will run this code and we'll see if the document with the name agentic AI python notebook.txt has been loaded into our file or not. Okay, so here is our file status, and let's see. Now you can see agentic AI python notebook.txt document has been loaded. Okay, we will also see that what is the content of this text file. Okay, so let's see the content of this text file. Let's see the content of our text file that is loaded into our file explorer. Okay, so here I will click on the file name, and in the right side you can see the content of our text file that is converted into chunks is here. So here we can see three chunks with the character limit 100. Okay, so the first chunk is LangChain is framework for building application using large language model. The second one is it includes support for chains, agent memory, tools, and vector store like API And the third one is developer can integrate LLM with external data API and database using LangChain. Okay, so in this way we have completed our chunking. Okay, now in the next step, we will see how to generate embeddings and use FAISS. In this step, we will see how to generate embeddings and how to use FAISS. So this code snippet generate embeddings for our document chunks and then use those embeddings to create a FAISS vector store. So the first line of code is from langchain.googlegenai import Google Generative AI embeddings. So it imports Google Generative AI embedding class, which is used to create embeddings using Google's generative AI models. The second line of code is from langchain.vectorstores import FAISS. We have imported the FISS class, which is a library for efficient similarity search and clustering of dense vector. LangChain provide an integration with FAISS using this code. Okay. Now the next line of code is embedding model equal to Google Generative AI embeddings, and we have given our model. So this line create an instance of the Google Generative AI embedding model specifying model embedding 001 as the model to use for generating embeddings. And vector store is equal to FAISS dot from documents. We have given docs and embedding model. This is the core step where the FAISS vector store is created. Okay. Now we should break down it. So docs, this is the list of document chunks that were created in the previous step. And embedding underscore model, what is the role of this code? This is the embedding model that will be used to convert each document chunk into a vector or embeddings. Okay. Now we can say that FAISS dot from documents. This is a method which takes the document chunks and the embedding model. It calculates the embedding from each chunks and then store these embeddings in a FISS index. This index is optimized for fast similarity search, which is essential for finding relevant document later. Okay, so let's run this code. Our code has been run successfully. This means we have generated the embedding and store those embedding in FISS data store. Okay. In this step, we will set up a question answering chain using the loaded language model and the FISS vector store. So I will explain it line by line and with the meaning of the code. So first line of code is from langchain.chains import retrieval QA. So we have imports the retrieval QA chain from the langchain library. And why we have imported this? What is the role of retrieval QA? This chain is designed to answer question based on the retrieved documents. Now second line of code is QA chain equal to retrieval QA dot from chain type, and we have given LLM, we have given retriever, we have given chain type. Okay, so QA chain and this line of code creates an instance of retrieval QA chain. So let's look one by one about the parameter which is given into this code. So LLM equal to LLM. This assign the language model that is known as LLM you loaded earlier, which we have loaded Gemini LLM. Okay, so this line will load the Gemini LLM to the chain. So this is the model that will generate the answer to the question. Now second line of code is retriever equal to vector store as retriever. So this provide the retriever component to the chain, and vector store dot as retriever, it convert the FAISS vector store into a retriever object. When a question is asked, the retriever will search the vector store for document chunks that are most similar to the question's embedding. And chain type is equal to stuff. What is meaning of this? This is specifies the type of chain to use. The stuff chain type takes all the retrieved document chunks and stuffs them into the language model's prompt along with the question. The language model then generate an answer based on this combined information. And response is equal to QA chain dot run. What is lang chain used for? So we have asked a question here. So this line run the QA chain, which is the input question. What is lang chain used for? The chain will first use the retriever to find relevant document chunks from the vector store, then pass those chunks and the question to the language model to generate an answer. After that, print answer and response. So this line print the answer generated by the language model. Okay. So we can say in summary, this code connect your language model and your document embedding that is stores in FISS vector store to create a system that can answer question based on the content from your document. So let's run this code and let's see what is the output we get. Okay. So our question and answer system has given this answer. So LangChain is used for building application using large language model. It helps developer to integrate LLM with external data. API, and database. It provides support for chains, agent memory, tools, and vector stores. So it has taken the chunks from our embedding data stores and it return the final answer as a result. Okay. So we have seen today what is vector store. So vector store stores the document embedding for similarity search. And what is FISS? FISS is a fast open source vector store which is used locally. And what about embeddings? Embedding converts text into numerical vectors. And use case, we have created a Q&A bot over document using FISS plus Gemini. And in next module, we will combine everything to build a RAG pipeline and multi-agent AI system. So see you soon in the next module.